Hello everyone, I hope you all are doing good. I'm Dinesh, final year student pursuing computer science from Welfare Institute of Science, Technology and Management. On behalf of my team members and my team mentor, I would like to present our final year project, which is a file sharing model using multi-layered image encryption technique over internet. So we proposed a system to maintain data confidentiality even when a data breach occurs with the help of steganography and numerous encryption algorithms. Most of the times, files which are stored in cloud is either encrypted once or not at all encrypted. This happens mostly when the cloud is hosted on a public domain, and this could lead to vulnerabilities while sharing files from one end to another. Our aim is to overcome such vulnerabilities by assigning multiple public keys to any given file for encryption. A given file can be divided into n modules, which are encrypted individually with n number of unique keys, respectively, which will potentially increase the security of a file by n times. Few of the cloud threats that we will overcome with our solution are data breaches, malware injection, insecure API calls, denial of service attacks, data loss, and man-in-the-middle attacks. We are making use of multi-layered algorithm to encrypt each generated module with the help of encryption keys. To decrypt a chunk of file, we need one possible key out of 70 septuagentillion generated keys of combination. The following flowchart depicts architecture of our system. Here sender wants to send file M securely using our system. He has to input file M along with recipient details of the person to whom this file is to be sent. The recipient details should consist of receiver's mail ID and his mobile number. After which the encryptor will go through three phases. So the first phase will be to divide files into chunks, which is followed by encryption and steganography mechanisms. And the encrypted modules will be stored in a centralized cloud storage area. The encryption algorithms which are used here are ASCII alteration techniques, rehashing with the help of logical operators such as XOR and OR, MD5 conversions, steganography techniques, block cipher techniques. The following image depicts the formula that we have created for encryption with the help of above algorithms. Phase 2 is a simultaneous process which runs in parallel with phase 1, in which the encryption key assigned to each chunk in phase 1 is stored in the form of record in another storage area. Phase 3 come into role after execution of phase 1 and phase 2, in which a steganographed image of size 200 KB is generated, which holds essential parameters which links with the required file stored in the cloud, and this image is sent to receiver over mail. The receiver has to use decryptor to fetch the file and decode the encrypted modules into the actual file. The decryptor accepts two inputs, which is the received image and the email address in which the image was received. After which the provided email address will be matched with the records stored in server, confirming authenticity of the receiver with the help of OTP. If records are matched following with the correct entry of OTP, the encrypted modules will be fetched from server along with the altered ASCII pattern table used while encrypting the file, with the help of which the actual files can be formed accordingly. The interesting fact here is the modules are created in main memory itself, which provides total abstraction to end users without letting them know about the modulation process. Following image is a sample chunk image formed after steganography process. The existing model is IPFS, and our method has some enhancements. IPFS makes use of blockchain, whereas we don't use blockchain model. IPFS is bound to model traversing, and so we are. IPFS makes use of asymmetric encryption, and we make use of symmetric encryption. IPFS generates one public key to access file, whereas we only check for authenticity, which makes direct interaction of file without the use of a key. In IPFS, whole file is encrypted using single key, and a single public key is generated. Whereas in our method, chunks of file is encrypted using different unique keys. In IPFS, the usage of main memory is more, as whole file has to be placed on main memory. Whereas in our method, the usage of main memory is very less, as chunks of file is encrypted individually. Here are some articles which shows data breaches which happened in a recent year. So nearly 9.7 billion data has been breached since 2013, and out of which only 4% of breaches was secured breach, where encryption was used, and the stolen data was rendered useless. Uh, Here are the steps of our encryption model, which I have discussed before. Here you can see the EBC card, which is the image which will be received by the receiver, right? And when compared with QR code, we are more efficient. You will be able to fetch 1 TB of data with the help of this simple 200 KB of our generated EBC card. Here are the stages which explains the encryption process, which I have discussed before. Here are the importance of moduling. So why moduling? Dividing the files into modules is always safer, as it lowers the risk factor of man-in-the-middle attack. In addition, each module is assigned with its own unique key in our system, providing more security to the files. Modulation also helps in less consumption of main memory while encrypting, thereby letting other tasks to run normally. Here is how the decryptor looks like. I mean, this mechanism was also explained by me previously. Here are the stages of decryption as discussed before. So why we are providing a robust and reliable model of file sharing via Google Drive, Dropbox, or any other cloud service. So more importantly, it is more likely to carry a key which opens or executes after successful authentication. That's what our model depicts. That's some screenshots of our platform. Here is how a receiver will receive the mail along with the final image. I would like to thank my team members and my mentor Dev ma'am, principal sir, James Stephen sir, and all other CSC faculty members and my friends who have always supported me. Thank you.